Principles of Electronic Communication Systems. Chapter 21, Wireless Technologies. Topics covered in Chapter 21: Wireless LAN, PANs and Bluetooth, Zigbee and Mesh wireless networks, WiMAX and metropolitan area networks, infrared wireless, radio frequency identification and near-field communication, ultra-wideband wireless. Wireless LAN. In addition to cell phones, there are many more wireless systems and applications in common use today. These are primarily short-range systems that have a range of few inches up to several miles depending upon the application. Each of these are popular systems is defined by a specific industry standard and is identified with one or a few well-known applications. Local area networks LANs within a company or an organization are still interconnected mainly by Cat5 or Cat6 twisted pair. Wireless extensions and even complete wireless LANs have become more common now that reliable, low-cost wireless modems are available. Wireless is a great way to expand an existing network. What makes the wireless LAN so appealing is that it offers flexibility, convenience, and lower cost. Wireless access points (APs) are available not only within offices but also in restaurants, coffee shops, airports, hotels, convenience centers, and other public places. Access points are more commonly known as hotspots. Some cities are installing municipal hotspots. Anyone with a laptop equipped with a LAN modem interface can link up to the AP and access his or her email or the internet. There are hundreds of thousands of hotspots around the world. As long as the computer is within the range of the AP, the connection is automatic. Wireless LANs also serve our continuing need to be more mobile in our jobs and activities. Another growing use of wireless LANs is in the implementation of home networks. Installing a wireless LAN is a fast, easy, and very inexpensive. A special box called a residential gateway or wireless router connects to the cable TV or DSL and serves as the access point. This gateway or router uses a software approach called network address translation to make it appear as if network PC has its own internet address, when in reality only the one associated with the incoming broadband line is used. Hardware of wireless LANs. The hardware devices in a wireless LAN are the access point or a gateway, router, and the radio modems in the PCs. The access point is a box containing a transceiver that interfaces to an existing LAN by the way of Cat5 or Cat6 wiring. It gets its DC operating power via the twisted pair cabling. The IEEE 802.3 AF standard related to furnishing DC power over the network cable is referred to as Power over Ethernet (PoE). In a home network, the gateway or router is designed to attach to the DSL or cable TV modem with Cat5, Cat6 cable. It often attaches to one of the PCs in the home network by cable. The other PC is linked to the gateway router wirelessly. One standard for wireless LANs has emerged as the most flexible, affordable, and reliable, known as the IEEE 802.11 standard. It is available in multiple forms for different needs. The earliest useful and most widely adopted version of the 802.11 standard is 802.11b. It operates in 11 channels in the 2.4 GHz unlicensed ISM band. This band extends from 2.4 to 2.48 135 MHz for a total bandwidth of 83.5 MHz. access method is direct sequence spread spectrum so that multiple signals may share the same band. The 802.11b standard specifies a maximum data rate to 11 Mbps. This rate is achieved only under the most favorable path conditions. Increasing range or noise causes to the rate automatically drop off to 5.5 to or 1 Mbps, which helps ensure a reliable connection despite the lower speed. The newest standard is the 802.11n version. It uses the 2.4 GHz band and OFDM. A primary feature of this standard is the use of multiple input, multiple output antenna system to improve reliability of the link. Apps for 802.11n use 2 or more transmit antennas and 3 or more receive antennas. The wireless nodes use similar arrangement. In its case, multiple transceivers are required for the AP and the node. MIMO systems reduce multi-path problems and extend the range and reliability of the wireless link. Wireless LAN standards, wireless security. The 802.11 standard also includes provision for encryption to protect the privacy of wireless users. Since radio signals can literally be picked up by anyone with an appropriate receiver, those concerns about privacy and security should use the encryption feature built into the system. The basic security protocol is called Wired Equivalent Privacy and uses the RC4 encryption standard and authentication. WEP may be turned off on by the user. It does basic level of security. However, WEP has been cracked by hackers and is not totally secure from the most high-tech data thieves. Two stronger encryption standards called Wi-Fi Protected Access and WPA2 are also available in several forms to further boost the encryption process. The IEEE also has security standard code 802.11i that provides the ultimate in protection. PANs and Bluetooth. A personal area network is a very small network that is created informally or on an ad hoc basis. A PAN typically involves 2 or 3 nodes, but some systems permit many nodes to be connected in a small area. PANs can be wired, but today all are wireless. The most popular wireless PAN system is Bluetooth, a standard developed by the cell phone company Ericsson for use as a cable replacement. Bluetooth is a digital radio standard that uses frequency hopping spread spectrum in the unlicensed 2.4 GHz ISM band. 3 levels of transmission power have been defined depending upon the application. Bluetooth transceivers are available as a single chip transceivers that interface to the device to be part of a PAN. Bluetooth transceivers send out search signals and then listen for nearby Bluetooth-equipped devices. If another Bluetooth device comes into range, Bluetooth devices automatically interconnect and exchange data. This device forms what is called a piconet, the linking of one Bluetooth device that serves as a master controller to up to 7 another Bluetooth slave devices. Bluetooth devices can also link to another piconets to establish larger scatternets. The main application for Bluetooth are cordless headsets for cell phones, wireless connections between PCs or laptop computers, and PDAs. Bluetooth applications include laptop connection at meetings, wireless printer to PC connections, laptop to cell phone connections, wireless audio headsets, and wireless digital camera to TV set connection. The Bluetooth standard is maintained by the Bluetooth Special Interest Group and supported by more than 2,000 manufacturers. Zigbee and Mesh Wireless Networks. Zigbee is a commercial name for another PAN network technology based on the IEEE 802.15.11 wireless standard. Like Bluetooth, it is a short-range technology with networking capability. It was designed primarily for commercial, industrial, and home monitoring and control applications. Zigbee is designed to operate in the license-free spectrum. Zigbee's virtue is its versatile networking capability. The standard supports three topologies: star, mesh, and cluster tree. The most commonly used are the star and mesh. These network topologies are made up of three types of Zigbee nodes: Zigbee coordinator, Zigbee router, Zigbee end device. The Zigbee coordinator initiates a network formation. There is only one Zigbee coordinator per network. The Zigbee router serves as monitor or control device that observes a sensor or initiates off-on operations on some end device. It also serves as a router as it can receive data from other nodes and to transmit it to other nodes. The Zigbee end device is simply an end monitor and control device that only receives data or transmits it. In the mesh topology, most of the nodes are Zigbee routers that can serve as monitor and control points and can also repeat or route data to and from other nodes. The mesh topology can greatly extend the range of the network and enhance its network reliability or robustness. Zigbee can address a wide range of wireless needs. It was designed primarily for monitoring and control. Monitoring refers to looking at a wide range of physical conditions, especially temperatures, humidity, pressures, the presence of light, speed, and position information. Control refers to the sending of command signals to initiate some action. Typically, commands are used to turn things off and on, such as lights, motors, solenoids, relays, and other devices. Popular applications of Zigbee include monitoring and controlling lights, heating, ventilating and air conditioning system in large buildings, industrial monitoring and control in factories, chemical plants, and manufacturing operations, automatic electric and gas meter reading, medical uses such as wireless patient monitoring, automotive sensor systems, military battlefield monitoring, consumer applications such as home monitoring and control, remote control of other objects and security. Metropolitan area networks are primarily fiber optic networks, most often SONET rings that connect enterprise LANs to WANs or the Internet backbone. Another typical MAN is local cable TV network, a new wireless contender for metropolitan area networking is known as WiMAX. It is defined by the IEEE 802.16 standard. It was developed to provide a wireless alternative to consumers for broadband internet connections. These connections are now dominated by cable TV and DSL, but with the new WiMAX standard, wireless internet service providers may soon be offering wireless broadband connections. The primary standard is known as IEEE 802.16-2004 or 802.16d. Its primary application will fit into two basic categories: point-to-point P2P, point-to-multiple point PMP. The P2P mode is for application requiring the transfer of data between 2 points. The PMP mode is broadcast mode from a central base station to multiple surrounding nodes. In this mode, WiMAX serves as a WISP for homes or businesses. WiMAX uses a 256 carrier OFDM system with adaptive modulation. The OFDM method lessens the line of sight problems that occur in serving a large area. Reflections from buildings or signal absorption by trees and houses make reception poor or stop transmissions altogether. A mobile version of WiMAX is now available. The standard is IEEE 802.16e 2005. It is designed to permit nodes to be mobile while maintaining contact with a base station. WiMAX is especially attractive to developing countries where a wireless infrastructure is easier and less expensive to install than a traditional wired telephone or cable TV system. Infrared wireless. Perhaps the most widespread wireless system uses infrared light to short distance data communication. The most widely used is the wireless remote control on TV sets, VCRs, and DVD players and on most audio CD stereo system. Infrared has also been used for wireless LANs and PANs. TV remote control. Almost every TV set sold these days, regardless of size or cost, has a wireless remote control. Other consumer electronic products have remote controls including VCRs, cable TV converters, and CD-DVD players, stereo audio systems, and some ordinary radios. Generic remote controls are available to hook up to any device that you wish to control remotely. All remote control devices work on the same principle. A small handheld battery-powered unit transmits a serial digital code via an IR beam to a receiver that decodes it and carries out the specific action defined by the code. A TV remote control is one of the more sophisticated of these controls, for it requires many codes to perform volume control, channel selection, and other functions. The keyboard is a matrix of single pole, single throw, push buttons. The row and column connections are made to a keyboard encoder circuit inside the IC. When a key is depressed, the pulse from one of the column outputs are connected to one of the row inputs. The encoder circuit converts this input to a unique binary code representing a number for channel selection or some functions such as volume control. The serial output is generated by the shift register as data is shipped out. A standard then returned to 0, serial code is generated and applied to a serial encoder. The serial bit stream turns a higher frequency pulse surge off and on. The pulse modulates the IR light source by turning it off and on. The IR source is usually one or more IR leads. Two or more leads are used to ensure a sufficient level or IR adhesion to the receiver in the TV set. In an IR receiver, the pin IR photodiode is mounted on the front of the TV set, where it picks up the IR signal from the transmitter. Two or more high-gain amplifiers boost the signal level. The incoming pulse are detected, shaped, and converted to the original serial data train. This serial data is read by the control microcomputer that is usually part of the TV receiver. The microcontroller inputs and decodes the incoming signal and issues output control signals to all other circuits. IR PANs. Besides remote control, the primary application for IR data communication is in short distance between computers and printers, or ad hoc PANs. Distance links typically up to 1 meter. However, under some conditions, the distance can be extended to 9 meter. There must be a clear line of sight between the transmitter and receiver. An IR transceiver connects to interface circuitry in the PC or PDA. The interface is typically a small embedded controller inside the computer or PDA. The encoder puts the serial digital data from the PC or PDA into the proper format for transmission. A high current bipolar transistor or MOSFET drives one or more IR leads. The receiver consists of the pin diode that picks up the IR light from a nearby transmitter. The signal is amplified and shaped and then sent to the decoder, which recovers the original data. Although many laptops and PDAs have a built-in transceiver. Their use is often restricted by this need for line of sight. A better arrangement is a transceiver dongle, which consists of a cable attached to the interface in the PC or PDA, and to the movable dongle containing the LED and pin diode. The most widely used IR data communication system was developed by Hewlett-Packard. It has since become an international standard that is maintained by the Infrared Data Association. The complete interface and system are referred to as Infrared Data Association. The systems are designed for a short range of between 20 to 30 cm and 1 meter. The maximum usable range is 8.9 meter. Most systems use data speed rates of 4 Mbps, however, a 16 Mbps version is available. Infrared Data Association does not use a modulation IR beam but rather baseband transmissions that requires encoding and decoding. The standard NRZ serial data is converted into pulse especially encoded for IR operation. The 4 Mbps version uses another encoding scheme called 4 ppm pulse position modulation. Radio frequency identification and near-field communication. Another growing wireless technique is radio frequency identification. Radio frequency identification uses thin inexpensive tags or labels containing passive radio circuits that can be queried by a remote wireless interrogation unit. The tags are attached to any item that is to be monitored, tracked, accessed, located, or otherwise identified. Radio frequency identification tags are widely used in inventory containing and parcel, shipping, capital equipment, and other asset management, baggage handling, and manufacturing and production line tracking. Other applications for radio frequency identification tags are personnel security checking and access, animal tracking, and theft prevention, automatic toll collection, and parking access for vehicles. As the technology develops, prices drop and new applications are being discovered. The tag is a very thin label-like device into which is embedded a simple passive single-chip radio transceiver and antenna. The chip is also contains a memory that stores a digital ID code unique to the tag item. For the item to be identified, it must pass by the interrogation or reader unit, or the reader must physically go to a location near the item. The radar unit sends out a radio signal that may travel from a few inches up to no more than 100 feet or so. The radio signal is strong enough to activate the tag. The tag rectifies and filters the RF signal into direct current that operates the transceiver. This activates a low-power transmitter that sends a signal back to the interrogator unit along with its embedded ID code. The reader checks attached computer where it notes the presence of the item and may perform other processing tasks associated with the application. Most recent new RFID standard is code Gen 2 for second generation. The standard is under the auspices of EPC Global, the organization that also standardizes the electronic product code used on all tag items. A key benefit of the new standard is that it is designed to read multiple tags faster. Tag read rates as high as 1,500 tags per second are possible. The Gen 2 tags can operate reliably in an environment with multiple readers transmitting and receiving simultaneously. One of the newest forms of wireless is a version of RFID called Near Field Communication. It is an ultra-short range wireless whose range is rarely more than a few inches. It is a technology used in smart cards and cell phones to pay for purchases or gain admittance to some facilities. Perhaps the newest and most unusual of wireless is known as ultra-wideband wireless. There are two basic forms of ultra-wideband. The original version based on very narrow impulses and the newer kind based on FDM. The original ultra-wideband, also known as impulse baseband or carrierless wireless, transmits data in the form of very short pulse, typically less than 1 ns. Advantage and disadvantage of ultra-wideband. Ultra-wideband offers many benefits to radar, imaging, and communication applications. Superior resolution in radar and imaging. Immunity to multipath propagation effects. Higher data rates than are possible with other wireless technologies. License-free operation. No interference to other signals using the same frequency band. UWB signals appear as random noise to conventional radios. Power efficient, extremely low power operation. Peak power levels are in the milliwatt region and average power in microwatts. This low power severely limits the range of operation. Simple circuitry, most of which can be integrated in standard CMOS. Potentially low cost. Primary application is impulse. UWB to date has been in military radar. UWB radar is used by fire, emergency and police personnel to see through walls and doors. Medical version permit body imaging for diagnosis. Low cost short range UWB radars that can be used in cars and trucks for collision avoidance. Automatic braking improved airbag deployment and suspension system are under development. Target markets for UWB include computer peripherals and wirelessly connecting video equipment.
Thanks for watching. Don't forget to like the video. And don't forget to subscribe.